Hello and welcome today to the Bourget Air Show at a very special booth. It's the Wallonia booth. Wallonia, make no mistake, is the other land of aviation because here we do a lot of things. Drones, lasers, machine guns, rockets, parts of aircraft, parts of engines, space technology. But we'll start right away with FN Herstal. We've finally arrived at FN Herstal, which is the champion of machine guns, of heavy machine guns. Here, this is the 12-7, which you know, but that's not what interests us in this presentation here. It's this system. Here, the goal is to be able to mount the whole assembly on the outside of the helicopter. And it can be operated both from the inside using the Sabre system, but we also have the option to lock it in place to make it work like a pod, which is traditional. Except here, it will allow us to save weight since we have equipment that can serve as both a Sabre system and a conventional pod. It has been approved with 2 calibers to already be integrated today into the U.S. Air Force, and the second one is the famous Gatling guns. The second little innovation from Herstal is this. This allows you to put the barrel inside, you can push it in, you can pull it out. But most importantly here, you've gained dozens of kilos of extra capacity, almost 38 kilos saved, because you have composites. So it allows you to carry 300 extra rounds on the heavy machine guns. We're arriving at Helix system with Jeffrey, who makes 3 drones. So the first one, what's its name?
Exactly. So here we have the Spartiate. It's a drone dedicated to anti-drone attacks. So it's going to crash into its target and explode in the propellers of a multicopter.
So it comes from below and then gets stuck in the Russian propellers?
Exactly. What will happen is that the propellers will be hit and destroyed. As soon as at least one propeller is destroyed, the machine will definitely fall.
So?
It's single use.
Just one detail, I see there's a solar panel. What's that?
Exactly. Actually, the goal is to keep the drone available at all times. And at that point, we can move the panel anywhere on the battlefield without any human presence or power infrastructure and have the machine stay connected continuously for several weeks.
Press the button, assign a target using its small camera, and it will handle the task automatically.
Through the C2, we send it a target designation, and it intercepts the target for neutralization.
Is it operational? Where do we stand?
We're testing now, and it should be operational by October. Excellent.
The second one?
It's also single use. So this one carries an explosive charge. This machine goes at 200 kilometers per hour. The goal is to be able to have, within a 40-kilometer range, either a GPS-designated target or a virtual one, like imagining a convoy at a certain location, and you target all the tanks for me. You can send it with several of its buddies. They'll automatically distribute the different targets among themselves and intelligently strike each one without needing an operator. Good loop.
Does that mean if we send 5 drones, we don't need 5 pilots controlling them? No.
You only need 1 operator even for 1,000 drones. We ensure the machine stays autonomous even when disconnected.
That means there's shape recognition and they'll divide up the tasks once they arrive in the area.
Exactly. They have a communication system that's very hard to jam because it's short range and uses unusual frequencies, which will allow them to communicate during the final approach phase and to divide up the targets.
I see there are some maps here. Are they made in Belgium or somewhere else?
Everything is made in Belgium, sir. Oh, no. We want to have 100% sovereignty, and we want to show that Belgians have know-how.
We already know that. And behind that, is there a third one?
Exactly. This machine can be fitted with 4 peripheral cameras to provide a 360-degree view 3D mapping capability and real-time recognition. And so all our machines have been designed to be manufactured at scale, even in less than ideal conditions. So this machine here, which we see being taken apart, it assembles in under 30 minutes in a trailer.
In a trailer? Okay, but what price range are we talking about? Is it still expensive or is it better suited to our field needs?
So I think it adapts pretty well. We're looking at around 1,500 euros for the anti-drone machine, okay? And it's 6,000 euros for the destruction machine. And it's 5,000 euros for the machine, so...
It's really not expensive. For reconnaissance, it can do mapping. Does that mean we can give it the information it collected a week ago so it can avoid the terrain? Absolutely.
The goal of mapping is partly to give operators a view of the terrain, but it's also for the drones to have autonomous navigation capability based on obstacles without having onboard sensors.
Thank you, Helix system.
With pleasure, thank you.
Let's continue. We're arriving at Safran Aerobuster because in Belgium there are parts from Safran. This is a low-pressure, high-speed compressor. It's equipped with instruments to test and validate it for more efficient next-generation engines. Here are blades. Be careful, these aren't ordinary blades. Here you have a weld. It's so clean that you can't even tell there's a weld. But on the other hand, what you notice here is that there's a small line, which actually means we have two materials, two titanium compounds that help improve efficiency, sharpness, width, and heat resistance. This makes this fan disc even more efficient than previous generations, with machining that is truly unique. And that's real expertise from Safran Belgium Aerobuster. This way we'll have better engines soon. We're arriving at Thales, Belgium with Thomas. Hello? Hello? Rocket specialist.
Exactly.
Why use a rocket instead of a missile? What's the difference today?
The basic difference between the two is simple. A rocket has its trajectory corrected. It's an initial propulsion. A missile has continuous propulsion, a lot more resources, and more maneuverability. So the rocket is a low-cost solution produced in large quantities, and it meets the needs of many platforms.
Apparently, we've multiplied the production of this rocket by 4 in the last 3 years. Is that right? So
We've multiplied by 4, and we're still growing today to meet demand in major export markets.
there are different warheads. I see what they're for.
So, we have different warheads. First, we have two main categories, unguided rockets and guided rockets. The principle of the unguided rocket is that you use them in slightly larger quantities. You saturate an area. Here we're working with a concept that we revealed 2 years ago at the Paris Air Show for anti-drone warfare. The principle is that we generate a cloud of pellets that allows us to destroy, initially of course, drone targets, drones, micro-drones, or small-sized drones. And today, given how the threat has evolved, this solution is also used to destroy larger drones.
That means that, well, when it's not guided, it's a bit like what we see with the Mi-8S in Ukraine. They go into a lofted position, they fire, and it lands on an area the size of a soccer field. At first, I doubted the concept, but they seem satisfied. So you provide this to Ukraine and it works?
It works well, and we've been supplying Ukraine since 2022.
So, can this be fired? Can a helicopter destroy a swarm of drones? Or does it have to be launched from the ground? No.
Initially, it was developed for ground use, but we know how agile and eager our clients are to test new concepts, so it can also be launched from airborne platforms.
So, is this typically the pod we would have?
So this is a pod that's dedicated to guided munitions. It's a pod that we currently find on the upgraded versions of European attack helicopters.
We can see it being carried under a drone above us. Is that just a concept or real?
It's more than real, and it's actually an old topic because we've been studying it for over 3 years now. We've carried out numerous firings, and today these are solutions that are also being deployed in the field.
In this case, what type of aircraft is it typically used on? So,
the launcher solutions, as you can see here, are present across the entire Airbus range, the entire Leonardo helicopter range, but we're also present outside of Europe on platforms such as those at HAL in India.
okay, and here, what's the diameter?
It's a 70 mm diameter, so it's the NATO standard.
NATO standard, but not French, because we chose 68 mm. We're the only ones, right, on our own.
So, hydrophobic means it repels water, so it prevents water from settling on the surface and therefore helps avoid, for example, issues like icing or things like that.
We're protecting planes or drones from icing.
Exactly.
With lasers, without changing the structure or adding a protective film.
Without adding a film, without using chemicals, we only modify the micrometric topography of the surface, okay? We also have other applications, for example, for glass. We can also make glass super hydrophilic, which allows us to keep the vision and transparency properties, which are even improved, while preventing any droplet deposition and accumulation on the surface.
Because hydrophilic means the drop will spread out and we can keep seeing through it?
Exactly.
So what is this?
Hydrophilic surface.
So here it wouldn't be, yes, we can see that it flows well.
There you go. So the water spreads out, it doesn't accumulate.
It doesn't form droplets. There you go. And the other side, is it treated?
The other side isn't treated.
And so here the drops will just run down and stay there.
They will stay on it.
Okay. So is this absorbent then? Well, it's absorbent, so
It's hydrophilic.
it's super hydrophilic.
So here,
We don't get it wet.
the water doesn't stay on it.
Okay, so is this one hydrophilic?
This one is super hydrophilic. Here the water is meant to spread across it.
Okay,
That allows you to control how water is deposited on it.
excellent.
Thank you too.
We're arriving at MachineSight with Pascal. As the name suggests, it's machine and sight. Why?
Well, machine because we make automated robotic and mechatronic equipment. That's the machine part. And sight, because we include automated visual inspection equipment, so cameras, lighting, and software behind it that analyzes the images.
We do quality control. Does that mean Industry 4.0?
It's Industry 4.0 in quality control.
Can we see the machine? Sure. What is its function?
So the machine here does two things. It performs handling. So it will take the compressor blades here that have just been forged. And so it will do analysis. It will take several images. So the robot will bring the blade to the different correct positions that have been programmed to take the best possible images of the entire surface of the blade. So depending on the depth of field and the lenses that have been used, it will also create silhouettes using the lower lighting.
Does that make it faster and more efficient than with a human?
A human, if they have to do that all day, at some point their mind will wander completely elsewhere. So here we don't want to replace humans. Besides, ESA doesn't allow it for now. But we want to create an assistant that can tell a human, be careful, there's something there, but it's up to you to make the decision. And the decision will be made on the user interface that we'll see later, where we'll be able to analyze the images.
Honor to Belgium, to the homeland. Our arms are yours.